Hi everybody. Welcome to section 4.5, scatter plots and predictions. Notice we're going to kind of do two things here. We're going to interpret points on a scatter plot. We're going to talk about correlations. And we're also going to write equations for a line of fit, which means we're going to have data. So the first thing that you need to know, and if you look at the examples that are kind of down the page, a scatter plot is a graphical representation. It's got an x-axis and a y-axis of data with two variables. So we could, well, let me go through this and then I'll say what we could do. We can show a pattern in the data if there is any. Sometimes things look like they match up and sometimes they don't. And we can use this scatter plot and this data to make a prediction about things. So for example, we could talk about a scatter plot. Let's say test grade. And down here, I'm going to put time studying. And maybe our scatter plot looks like this. So we can kind of look to see at that information to see if there is a pattern, if it looks like there's some kind of connection between the time spent studying and a test grade. So a line of fit is a line that fits best through the data. It will not touch all the points. So it kind of looks like in my time studying and test grade, sort of looks like there might be a line that kind of fits through like that maybe. We can't be real exact. They don't form a nice, neat line like all of our linear equations have, but it sort of looks like it fits through there. And there's a couple that are way out, a little high, a little low, but it looks like it fits through there. So that would be our line of fit. Notice it looks like it kind of hits pretty exact on a couple of those points. So our prediction equation, first of all, if we're predicting, answers will vary because we're estimating. We can make predictions about all sorts of things, presidential elections, the weather, but answers will vary. We don't really know. We've got a pretty good idea. And what we're going to do to write a prediction equation is we're going to find the slope and we're going to use a point on the graph. So we can do all those things. And I'm going to give you some guidance on finding the slope so that we all are in the same ballpark. Otherwise, it could get a bit crazy. So let's talk about correlations. Correlation is a relationship between the two variables, how they relate, if at all. So you already have these three graphs in that little table. Think about the one that we just did with the time studying and the test grade. We saw that there was possibly a relationship, and it looked like as the time studying, let me go back to this for a second, it looks like as the time studying increases, the test grades increase.
Here's the following students to the Media Center. Derek Landis, Austin Lane, Heather LaFave, Eric Lachinsky, Jacob
All right, totally disregard that. That was an awkward technical difficulty. So as I was saying, we kind of look like it increases, right? As the amount of time studying increases, the test grades increase. At least we hope that's what's going to happen. So we're looking for that positive slope increasing. Positive slope means we have a positive correlation. The slope is going up. Notice on this personal income, I could make a pretty good line of fit through there. It looks, my line's a little wavy, it looks like it touches most of the dots, but not quite. It's not exactly linear. And we would say as X increases, Y increases, or as the years increase, the personal income in dollars increases. They'll also mention a strong or a weak correlation. Strong means that the dots are really, really close to the line. Weak means they're kind of all over the place, but they still look like it, like our test grade and studying one. Negative correlation, we've got ourselves a negative slope. And it looks like to me, this one's a little bit weaker than the last one, but it looks to me like probably that would be close to our line of fit. So as the years increase, the students sharing computers decreases because people have their own. And no correlation, there is no line of fit, there is no slope, there's no correlation that we can make at all. And so we would say that X and Y are not related, whatever they are. So let's talk about dependent and independent variables. I feel like we've talked about this before. Maybe I don't have anything there. So deep independent, remember, is always the X values. The X-axis, that's the values we pick on an XY table. The dependent are always the Y values. Remember, independent is also the domain. X values. Dependent are the Y values or the range. So when we've got a graph, we know that the independent goes down here, and these depend on what we have for our x-axis or x values. So linear interpolation, we're going to predict values inside the range of data. So we're going to look at a correlation and we're going to say, well, about how much would that be? Let me move this out of the way. About how much would that be? And it's inside the range of data. So if the years go from 2000 to 2016, we could interpolate something from 2010. It looks like it'd be pretty close to this. Extrapolation, I used to have that in there, means that we're going to predict values outside the range of data. So same example, if we've got information, data, a graph about something from the years 2000 to 2015, we would use extrapolation to figure out what's going to happen in 2050 or 2030 or 2020. So years are a good way, time's a good way to think of that. All right, so now let's talk about how to create a scatter plot. I'm going to go through this and then I'm going to tell you your lesson summary and practice is the big thing that I kind of step by step you through. So first thing you got to do to create a scatter plot is collect or be given data, because I'm going to give you the data. We're going to graph that data on graph paper. You do have to decide on your X and Y axes. So what is the independent variable? What is the dependent variables? We're going to draw that line of fit. And I called it a best fit line. Sometimes they call it different. Draw the line of fit, draw the best fit line, draw the fit line. It's not dot to dot. Remember, it is a straight line. It may not hit all the points. Then what we're going to have to do is, this is where we're going to start writing an equation. So we are going to then pick 2 points on that best fit line. Now here's what I'm going to tell you. Pick the second point and the second from the last point. This is not a scientific theory on doing this. It just makes life easier for all of us so that we're working with the same ordered pairs and we can come up with the same slope. Otherwise, I would have 32 different slopes and 32 different equations, and that would be really rough to try to figure out if you're on the right track or if you messed up on your math. So we're always going to use the second point and the second from the last point. And I'm telling you straight up, if it's not in order, put it in order. So second and the second from the last. You're going to use those 2 points to find slope. Everybody knows how to find slope. We're going to go back to our old-fashioned slope formula. That's why we spent so much time talking about it and writing equations. And then I'm going to use my point slope equation. So I'm going to use the slope I just found and one of those 2 ordered pairs from the second or the second from the last. So you don't get to pick any point on this one. We're going to use one of those 2. You'll get the same answer no matter which one you use. And then last but not least, solve for y, or if we're being technical, put into slope-intercept form. Y equals mx plus b. So really it comes down to make sure you choose those those points correctly, the second and the second from the last, because otherwise we'll be all over the place. So that way you'll know that you're on the right track. So this practice problem is your lesson summary. I didn't even put it on there. Lesson summary and practice problem. I step by step you through it. I gave you the data. So this is what I'm going to be looking for. So start off with looking at that minutes and score. The table below shows the number of minutes 18 students studied and their test score earned. Use the data to answer the following questions. So the first thing you need to do, number one, identify dependent and independent, and that's going to help you to put it on the graph. So what's going on the x-axis? So this will be the x-axis, or the independent variable. This will be the y-axis. My suggestion when you do graph these is to count by maybe tens, or do the little, count by tens on the y-axis. You should be able to count by probably tens on the x-axis as well. You might have one or two scores fall off the x-axis. But draw the scatter plot. So remember, we're going to just put all those ordered pairs on there, and we're going to look for a line of fit. When you determine the correlation, positive, negative, or none. And then for number 5, you're going to write a prediction equation. Use the second ordered pair and the second from the last. So it looks to me like the second ordered pair is this guy right here. The second from the last, we'll use the 9100. So use those two guys for number 5. Once you write that prediction equation, use the equation that you wrote in number 5 to predict the test score of a student who studied 25 minutes, and use that same equation that you wrote in number 5 to predict the test score of a student who studied 5 minutes. 5 minutes is not on the graph. We don't have any data from 5 minutes. Okay. That is it for lesson 4-5.